All right. No promises that this will be short, but I will do my best. I will be writing right on top of this because I've put it into my folder. Um, but hopefully, this will help you guys for any of the questions that you had on the review. So, number one was just solving for x without a calculator. So, you're going to subtract 1. I don't know why I'm writing like I am. Let's start this over. Sorry. All right. So then I get 3 log base 2 of x equals 6. Divide by 3. I get log base 2 of x equals 2. So go around the block here. So I start with the base of 2 to the second power equals x, which is 4. So in the yellow there, you should have put 4. All right, I'm also not going to go in maze order. I'm just going to go straight across because, again, this is just a picture, so the maze doesn't pop up when the correct answer goes in, and so I don't really remember the correct order. So, and yeah, I'm sure you want to see them all, right? All right, so this one says we need to satisfy the condition that the initial population is 67,000 and it's decreasing at a rate of 1.67% per year. We just want to name what is B. And so to do that, remember B is 1 minus the rate because it's decreasing. If it were increasing, it would be 1 plus the rate. The other thing you must remember is that that rate must be written as a decimal. And I put too many zeros there. 0. There we go. All right. Which equals 0.9833. Okay, so the function would be 67,000 times 0.9833 raised to the t power. But to get this question right, you only had to put in B. All right, for this one, if I want to expand, first thing I notice is that my division. So I know that that means minus. Okay, then I notice 2 multiplications going on here. So in the front half, we've got log of x cubed plus log of y, if I split that up. In the back half, I have log 10 plus log z, if I want to split that up using the properties. I have one more step here. I can bring the 3 down. So I have 3 log x plus log y. Here's the one that tripped a lot of people up, minus log 10. Remember, log 10 is actually log base 10 of 10. So that's saying 10 to the what power is 10? Well, that's 1. So it should be minus 1. And then also distribute that negative sign to get minus log z. The next one, the number of students infected with the flu at Olympia High School, T days after exposure, is modeled by this function. Yes, it's super tiny, sorry. What is the initial number of students infected with the flu? Initial number means I'm going to type in my calculator. Initial means T is 0, okay? So wherever T is, I'm putting a 0 there to see what my outcome is. If I round it, it is 5 for this one. So again, type that in your calculator, make sure that you can get that. But that's what I would type in Desmos. I know some of you had a hard time keeping the T or the X up in the exponent. If that is the case, use that extra set of parentheses that I added there. And that should keep T up in the exponent. All right, for the next one, it says, when will 100 students be infected? So in Desmos, I have many lines that I can type. In the first line, I'm going to type that function. So again, I use X. That's all raised to the power. That's all in one line of Desmos. You don't have to have the y equals or the p of t equals there. You just need the function if you're using X. Okay. Then in my second line, I'm going to put y equals 100. I'm going to zoom out, zoom out, zoom out, zoom out, zoom out until I can see 100 high. And then, so I'll actually put that in the calculator here. 300 divided by e raised to the... There may be a typo there. I'm going to go back and double check myself in just a second. I just don't want to make you super dizzy. All right. All right. So my intersection is right here, so approximately 3. I'll go ahead and hit this one too, because this would be another one. This is to the nearest day, so it would take 3 days for that to happen. Okay. For the last one here, it says, what is the maximum number of students infected? Well, if I keep zooming out, I notice that this bottoms or tops out at 300. So that's the answer for that one, 300. I know I said I was going to go from left to right, but all of those had to deal with each other. So I went ahead and answered that one so we didn't have to go back. All right. Same thing with these 3. We will do these 3 all together. It talks about a red wolf. We have this formula here. Remember, you can zoom in much better if you are looking at your own. And it says, we want, this is supposed to be represent. Good typo there. Represent the year 2012 in terms of the year 2005 being t equals 0. So in 2005, t is 0. 2006, t is 1. 2007, t is 2. So forth and so on. What would it be in 2012? T would equal 7. If you type that in with no spaces, you will get that question correct. Okay. So that follows right along into this one right here, because it says, what is the population in 2012? So all I'm doing there is typing 13 plus 75 over 1 plus 24 e to the negative 0.4 times 7. Okay, and I think I also had a typo there where I had an R. They should have all been T's for time. All right. So I get 43. Okay. Finishing the red wolf. Again, when you graph that, I'm going to save time because this video is long enough as is. But just like the flu question that we did and how it topped out at the top, this one will do the same, and it should top out at 88. So try that on your own and see if you can get that same top population. All right, this is a calculator active problem. So I think that's what threw some of you guys for a loop when you needed to solve this. It is currently in exponential form, and we need to solve for logarithmic form. So I'm going to do log base 17 of 12.6 equals negative 3a. We're going to divide by negative 3. I now have a by itself, so I'm just going to type all of this in my calculator as is, because again, it's calculator active, but I don't want to type it in the calculator until then. Okay. So I had log base, which you can just do log and a sub, an underscore, and that will make the subscripts for you to type 17. I'm on an iPad, so I don't have that same functionality here, so I'm just going to do it like this. And so that is your answer. And the question said to round to the nearest 10,000th. So that is 4 decimal places. 4 decimal places. All right, next. We're solving for x again. Remember, I can rewrite log cube root of 10 as log 10 to the 1/3 power. So if I convert forms there, I would get, sorry, that's an x. 10 to the x power equals 10 to the 1/3. Well, notice this must equal this, therefore x must equal 1/3. Okay. So if I think about this being ln of e to the -7th, because 1 over e to the 7th, my exponential properties from algebra 1, I can bring that up to the numerator as a negative. Then I think about ln being the same thing as log base e of e to the -7. Those are inverses of each other, so I'm just left with -7. I could also think about making it equal to x and converting forms. And then it becomes very similar to the last problem where they must equal each other. All right. Next, subtract 8. I'm going to get log base 2 of x plus 2 equals 3. Notice it's calculator inactive. So 2, this is where I convert forms. This is what a lot of people are forgetting. Base 2. So 2 to the 3rd power equals x plus 2. 2 to the 3rd power is 8. And so if I subtract 2, I get x equals 6. All right. The next question is the end question. It is a little harder, but if you can solve this equation, you can solve any logarithmic or exponential equation ever. So that's why I put it on here just kind of as like the advanced last problem. All right, so first you're going to add 10. Let me make this thinner. All right. All right. Then I'm going to divide by -7. And so that's going to give me e to the 2.7x plus 6 equals -5.2. Thinking about e being the same as switching it to log base e if I were to convert forms, so the bases. So log base e is the same thing as ln. timeout. This is no longer negative because I divided by negative, sorry, but it is 5.2. So ln of 5.2 equals 2.7x plus 6. So ln of 5.2 minus 6 equals 2.7x. I would divide on both sides here. And this right here is what I would type into Desmos for the final answer. So you can go ahead and try typing that into Desmos to make sure that you know what you're doing. And you should get negative 1.6116. If you get that, that is correct. Again, make sure to use those parentheses there because the ln of 5.2 ends. You find a number for that, then you subtract 6 and divide. All right, next problem. We are going to rewrite as an exponential. So 3 to the x power equals 3 to the 8th. Or sorry, 3/8. I don't remember which answer that is in the multiple choice there, but you can select that one. If I am condensing, I need to first bring the number out front up as a squared there. That was a terrible squared. Bring the y becomes y cubed because again, you are bringing those numbers up as exponents according to the property. Then you have ln x squared y to the 4th minus ln of y cubed. Well, remember that minus is actually division, so it's ln of x squared y to the 4th divided by y cubed, which is just ln of false. X squared y, because y to the 4th divided by y cubed is just y. Okay. Expanding, same idea. You must remember that square root of xy is the same as to the 1/2 power. So I would have 1/2 log xy minus log 3. Since that adding is going on in between there, or sorry, multiplication is going on in between there, that means adding. If I'm expanding. And last but not least, I can distribute that 1/2. So for you to get this right, it's 1 divided by 2 log x plus 1 divided by 2 log y minus log 3. Okay. This one is just like that second or third question. I don't remember which it is, but this time we are increasing. So we are doing 1 plus 0.0167, which is just 1.0167. And again, you are just putting in B to get that one right. Remember, your copy probably has a typo right here that says 3 instead of 4. I've already fixed it on my copy because I knew if I didn't do it now, I would never remember to do it for next year if I plan to use this next year. All right, so using my properties, I have x plus 2 times x minus 4 equals ln of 2 to the 4th power. My ln's are going to cancel, so I have x squared minus 2x minus 8 equals 2 to the 4th power is 16. I have a quadratic function, so I have to subtract and set equal to 0. Why? So hopefully I can factor. And so how do I factor, in case you forgot? What multiplies to get negative 24 but adds to get negative 2? That is negative 6 and 4. So x would have to equal 6 and x would have to equal negative 4. It says to only state the extraneous solution. The extraneous solution is the one that makes finding ln of a negative number, because I can never find ln of a negative number. So if I plug this back into the very original equation here, if I plug in 6, I get 6 plus 2, 8. ln of 8 is fine. Then I get 6 minus 4, which is 2. ln of 2, that's also positive. Everything's fine. But if I plug in negative 4, I get negative 4 plus 2, which is negative 2 here. And then negative 4 minus 4 is negative 8. Neither one of those are okay. So negative 4 is our extraneous solution, which means it's not actually our solution. Our real solution is 6. Okay, and the last one of the maze, we are just rewriting our base is 3. So that means our base of the log is 3. So log base 3 of m equals x. Again, I don't remember which one exactly that is, but that is the answer. And then last but not least, our graphing one here. First thing I'm going to do, notice it is calculator active. I am going to, let's see, type it in. So x squared minus 3x minus 4. All right, so my domain is approaching negative 1 and approaching 4. So the domain is negative infinity. Oh no, where did it go? There it is. Sorry, that got you a little dizzy. Negative infinity to negative 1, and then 4 to infinity. My range is everything. It does keep going up. It is very hard to tell on that graph. So what I will tell you is, if I were to find the inverse of this, I could plug in any x value to the inverse. And remember, the domain of the inverse is the range of the function. So the range is negative infinity to infinity. So where is it increasing? It is increasing from 4 to infinity. Remember, it kind of looked like this. Okay, so before I was interrupted and cut off, remember our graph kind of looked like that. So it was increasing on this side and decreasing on that side. We have 2 vertical asymptotes, so one at negative 1 and one at 4. There are no horizontal asymptotes and there are no holes. All right, so this completes the review. Whatever you still have questions on, feel free to either shoot me an email or be ready to ask me first thing when class starts, or come see me during Flex.